Hello and welcome to this presentation of the STM32H5 low power timers. It covers the main features of these ultra-low power timers. The low power timer peripheral embedded in the STM32H5 microcontroller provides a 16-bit timer that is able to run even in low power modes. This is made possible thanks to a flexible clocking scheme. The low-power timer peripheral provides basic general-purpose timer functions. One major function of the low-power timer is its capability to keep running even when no internal clock source is active when configured in asynchronous counting mode. The low-power timer's main feature is its ability to keep running even in low-power mode when almost all clock sources are turned off. The low-power timer has a very flexible clocking scheme. It can be clocked from on-chip clock sources, APB clock, peripheral clock or PerCK, LSE, LSI, PLL output P. Or it can be clocked from an external clock source over the low-power timer's LPTIM input. This latter feature is used for building pulse counter applications, as in a key function for metering applications like gas meters, etc. The low-power timer features up to 8 external trigger sources with configurable polarity. External trigger inputs feature digital glitch filters to cancel out faulty triggers that could be raised in noisy operating environments. The low-power timer can be configured to run either in continuous or one-shot mode. One-shot mode is used for generating pulse waveforms, while continuous mode is used to generate PWM waveforms. LPTIMs with implemented channels can be configured as either input capture or output compare. Two different events can trigger DMA requests, input capture and update event. The low-power timer is a peripheral split in two separate clock domains. The APB clock domain on the left of the figure contains the peripheral's APB interface, while the kernel clock domain contains the low-power timer peripheral core functions. The kernel clock domain on the right of the figure can be clocked by internal clock sources or by an external clock source through the timer's LPTIM input. The low-power timer peripheral embeds a 16-bit counter that is fed through a power of 2 prescaler. The low-power timer peripheral features a 16-bit auto-reload register and a 16-bit compare register that are used to set the period and duty cycle, respectively, for a PWM waveform signal output on the timer's LPTIM output, steered to either LPTIM-CH1 or LPT-CH2 output according to the PWM channel number. The low-power timer features a repetition counter which allows to adjust the counter rollover. At last, the low-power timer features an encoder mode function that can be used to interface with incremental quadrature encoder sensors using the peripheral's LPTIM MUX and LPTIM MUX inputs to select the direction. These input signals are visible on the upper right of this figure. All timer inputs support a glitch filtering circuitry. Note that LPTIM4 has a simpler block diagram. The LPTIM CCRX and LPTIM ARR registers, in conjunction with the bit fields wave from the LPTIM CFGR register and single start from the LPTIM CR register, are used to control the output waveform. The output waveform is either a typical PWM signal with its period and duty cycle controlled by the LPTIM ARR and LPTIM CCRX registers respectively, or it's a single pulse with the last output state defined by the configured waveform. If the last output state is the same as the one at the waveform's beginning, then one-pulse mode is configured. Otherwise, set-once mode is configured. The low-power timer's output polarity is controlled through the wave-pol bit field in the LPTIM CFGR register. By setting the polarity bit, the default state of the output is high-level, and the waveforms are ones complemented with respect to the ones represented in the figure. The PWM mode generates a signal with a frequency determined by the value of the LPTIM ARR register and a duty cycle determined by the value of the LPTIM CCRX register. the LPTIM is able to generate PWM in edge-aligned mode. Dynamic modifications of the PWM period or duty cycle can be performed by CPU or DMA accesses. The following PWM events can be used to raise an interrupt request: counter overflow, repetition counter underflow. The 8-bit repetition counter decrements at each counter overflow and triggers an interrupt when it reaches 0, which is convenient to adjust the interrupt rate. This slide describes the input capture features. Each channel can be individually configured as input capture with various signal conditioning options. The edge sensitivity is programmable and can be rising edge, falling edge, or both. An event prescaler captures of one event every 2, 4, or 8 events as programmed in the prescaler. Spurious transitions due to noise or bounces can be removed using a programmable digital filter. Once the capture trigger is issued, the timer's counter value is transferred into the capture register and an interrupt or a DMA request can be issued. If a new capture occurs before the previous one has been read, the capture register is overwritten and an over-capture flag is set for the software to manage this condition if needed. The low-power timer features a counter reset function used to reset to 0 the contents of the LPTIM CNT register. 2 counter reset mechanisms are possible: the synchronous counter reset mechanism and the asynchronous counter reset mechanism. Asynchronous counter reset is performed by setting the count RST bit. Due to the synchronous nature of this reset, it only takes place after a synchronization delay of 3 LPTIM kernel clock cycles. When the RST-A-RE bit is set, an asynchronous counter reset is performed on the next APB read access to the LPTIM CNT register. The low-power timer features an encoder mode function that can interface with the incremental quadrature encoder sensors using the peripherals input 1 and input 2. This mode allows handle signals from quadrature encoders used to detect the angular position of rotary elements. Encoder interface mode simply acts as an external clock with direction selection. This means that the counter just counts continuously between 0 and the auto-reload value programmed in the LPTIM ARR register. From the 2 external input signals, input 1 and input 2, a clock signal is generated to clock the LPTIM counter. The phase between these 2 signals determines the counting direction. Both inputs feature glitch filtering circuitry. The encoder function is similar to the one embedded in the general-purpose timers. In order to use the encoder mode function, the low-power timer must be running in continuous mode. One important thing to note is that only low-power timers 1 and 2 embed the encoder mode function. This table lists the interrupts and DMA request sources. The capture interrupt or DMA request is generated once the contents of the counter register LPTIM CNT matches or is greater than the compare register LPTIM CCRX contents. The compare match interrupt or DMA request is generated once the contents of counter register LPTIM CNT matches or is greater than the compare register LPTIM CCRX contents. The auto-reload match interrupt is raised when the counter register's contents matches the auto-reload register's contents. The external trigger event interrupt is raised when a valid external trigger is detected. The auto-reload register write OK, the compare register write OK, and the repetition register write OK interrupts are raised when the transfer of the contents of the LPTIM ARR register, the LPTIM CCRX register, or the LPTIM RCR register, respectively, is completed from the peripheral's APB interface logic into the peripheral's core logic, which are contained in 2 different clock domains. These 3 interrupts are useful in mitigating the overhead of polling on the status or writing to these status registers when the peripheral core clock is much slower than the APB interface clock. The up and down direction change interrupts are raised when the encoder mode function is enabled and the counting direction is changed from up to down and vice versa. The counting direction of the low power timer's counter reflects the rotation direction of the quadrathrust sensor. The update event interrupt or DMA request is generated when the repetition counter underflows and the LPTIM counter overflows. The low power timer peripheral is active in sleep and stop power modes. It's powered down and therefore not functional in standby mode. The low power timer wakes up the microcontroller from either sleep or stop modes. All DMA requests must be disabled before entering sleep, stop, and standby mode. For more details, please refer to the following documentation available on our website. In addition to this presentation, you can refer to the following presentations: Reset and Clock Controller or RCC, and Power Control or PWR.